Hello, everyone. Thank you for attending our webinar today here at FMS. Topic will be Streamline Your Drinking Water Sample Preparation and Analysis. And I'm Tom Hall, and Rude Addink, our technical director for our laboratory, is also here with me, and he will also be participating in the presentation. Okay, so our agenda today is we're going to be talking about fluid management, who we are just briefly. Then we're going to talk about sample prep versus analytical runtime, and just how much of that time is taken up by a laboratory in your sample analysis workflow. Then we'll talk about the sample prep workflow, and then we're going to talk about total solution sample prep and analysis strategy here. And as we go through this, you'll see that we have fully automated solutions for sample prep. So you put the sample in and get the extract out and go directly to the GC or mass spec for analysis. So FMS was founded in 1986, and our sole function and focus has been to manufacture total solution sample prep systems and consumables for GC, GCMS, LC, and LCMS analytical instrumentation to deliver the best possible cleanest extracts for the best possible results. Everything here at FMS is made in the United States. We're very proud of that. So we have a machine shop. We have all of our manufacturing here in Billerica, Massachusetts. This is an example of some of our valves that are made right here at our facility. This is a Class 1000 clean room, which is made and used for all of our consumables for manufacturing. And just to give you a little bit of a breakdown of the laboratory's workflow, we have a little graphic here that's been produced by the SDI Strategic Directions marketing folks. And extraction, sample cleanup, and concentration take up 65% of the laboratory's work and attention. 35% is on the analytical one side. So the FMS sample prep workflow goes like this. On the left, you have the PLE extraction for solids and semi-solid systems. Then you have solid phase extraction for water and liquid sample matrices, and we're going to focus on that, especially the drinking water today. And then you have the power prep family of cleanup systems. We have the power prep, we have the econo prep, we have the easy prep. There are many different types of sample cleanups. So we won't be really talking about that at all today. Then we have the SuperVap family of concentrators that we go directly to from these automated instruments and will automatically do the sample blowdown. And on the right, you have the total sample prep system example here, where we have a controller, a cleanup module, an extraction module, and you can see the tubings going directly to the SuperVap concentrator. And so what that does is it's going to eliminate any possibility of outside contamination from the laboratory. You put the sample in, you hit the start button, and you're going to go from the extraction, the cleanup, directly to the concentrator and blow it down to its final volume. The system will alert you as to when it's ready. Then you're going to go directly to the analytical equipment. So for solid phase extraction, the front end for GC mass spec and LCM mass spec, we have many different types of these extractors. We have the Econotrace, which can handle 2 samples per module in parallel, up to 8 samples in parallel, and this is primarily a positive pressure only system that is used for drinking water in clean matrices. Then we move over to the turbo trace, which is designed for those labs that handle drinking water and wastewater or groundwater samples. And it does 1 sample per module, and you can do up to 8 samples in parallel, and that basically will have 8 individual modules. Then you have the turbo trace AVN, which is a 2 cartridge system that's primarily used for pesticide cleanup, extraction, cleanup, and concentration. And you also are using that for semi-volatiles for 625, 8270, etc. Those require 2 cartridges to get the full list. And then we have a whole suite of turbo trace, econotrace, PFC systems. All of our systems can be turned into systems for PFAS and PFOS analysis. That's a very big drinking water application as well as wastewater. And then you have the nanotrace, which is focused on very small volume SPE, things such as serum and others. So the other main thing or specialty with our concentrators is you have the ability to go directly to the vial in our SuperVap concentrators. So this saves a large amount of time and reduces error because you're just blowing down inside of that tube, and it's going to go directly into the GC vial. You take that GC vial off and you put it directly into the analytical piece of equipment. So every time you're transferring, say, your extract out of a nipple, etc., you're going to lose a few percentage of your analytes. So this is a really helpful and useful feature of the SuperVap concentrator. You can see all the different types. We have 6 position, which is for large volume, 250 mil vessels. The 12 position, 50 mil vessel, that's very popular for most drinking water SPE applications, I'd say all of them. So 12 position is usually teamed up with our automated SPE extraction systems. And you also have 12 position, 20, 40, 60 mil BOA vial setups, which folks use that quite a bit. And then you have the 24 position 2 and 4 mil vial, which are used to go to final volume for dioxins and some other methods. We've also come out with a system that's specifically designed for PFAS, PFOS, we call it SuperVap PFC. It's got 24 positions. There's no Teflon components in it, and it handles 15 mil conical vials. So basically, when you're putting you're eluting into that 15 mil conical centrifuge tube, and then it goes directly into the concentrator for final blowdown. So our objective here is to develop as many SPE procedures for testing, in a lab on a single extraction platform. So basically, we're trying to minimize all the steps and lessen the error and maximize your limited man hours. So basically, if you have a couple of these systems, one person can easily run them. All they have to do is load the samples onto the system, make sure that these the solvents are full, the waste is empty, and you have the collection vessels in the SuperVap ready to go. The super high throughput, and it's low cost sample prep for liquids. Many of the reasons to switch to SPE are to reduce solvent. And so a lot of those methods that are liquid, etc., they use probably up to 4 times as much solvent. And so when you reduce the solvent, you're actually reducing the amount of solvent that is evaporated into the environment. So you're greatly reducing solvent usage and emissions, therefore waste. So you're going to save a lot of money on the disposal of solvent after the process. You're going to reduce your glassware. Basically, you have your sample bottle and your extraction vessel, and that's it. So automation versus manual protocols basically just equals reproducibility and throughput. You're going to have less mistakes. So if people aren't touching your the sample for each step, say for the extraction, the cleanup, and the concentration, if it's all combined together, you're going to get the most reproducible, highest recovery of results. These systems are also closed systems, which is important. So you don't have to have these in hoods. You're not pulling contaminated or contaminants from the lab into your sample, which is really important during the process. You can also handle samples with sample volumes of any size. So that's really important. There are a lot of techniques and even automated systems that can only handle a certain amount of volume. These systems are designed to handle anywhere from 2 mils to 50 liters. It doesn't matter. We just put our sample loading tube into the vessel and away we go. This doesn't require any custom sample tubes or sample caps. We just take the cap from the vessel that you use in the field and we modify those for you. So it ends up being a very low cost type of situation instead of having custom cap adapters, which a lot of folks for other types of units out there, that's what they have to have, and those are very, very expensive. We have the ability to load samples by positive pressure or vacuum. We're going to talk about these two systems. The first one will be positive pressure only, of course. And then we can easily handle a wide variety of cartridge designs and sizes without any cumbersome modifications, because we make all the adapters. We make a whole bunch of different cartridges. We can make custom cartridges for any of your needs. We have the ability to dry cartridges by vacuum and positive pressure, nitrogen or CO2 from the positive pressure side, but the vacuum does a coarse drying. It gets most of the water off, and then you use the positive pressure gas to do the fine drying, and it works really well. Then you're able to actually attach a drying cartridge to the concentrator, the SuperVap, and do the extraction, drying, and concentration all in one step. It has an automated bottle rinse, which does the automatically loads the solvent into the rinse bottle, and then the rinse bottle delivers the bottle rinse to the sample bottle when all of the sample is loaded across the cartridge. These are all parallel extractions, so everything is happening at the same time for high throughput, efficient use. So just some of the main benefits here. We talked about this a little bit earlier. The automated SPE is a closed system. Once you put the cap on that sample, there's nothing that's exposed to the outside world. Solvent usage is much, much less than this 360 mils if you're doing liquid or continuous shaking. So just a big savings here. And with this reduction in solvent, you're actually going to cut down a lot of your emissions to the atmosphere, which that's really, really important to think about. Or if that's something that is a problem for you, just by moving to automated SPE methods, you can avoid potentially expensive solvent reclamation solutions. This is a filtration process for solid phase extraction. So we're using, chemistry backbone absorbent to do the separation, where you're using a liquid to separate out the analytes, have them go to from the water into a liquid that's they're more susceptible. This can form emulsions, and when emulsions form between the water and that solvent, it encapsulates analytes, and so you get poor recoveries when that happens. You have almost no selectivity. It's basically whatever solvent you're using with water and shaking. The SPE is coming out with all different types of absorbent materials on a regular basis to do a better job of separating or isolating and concentrating your analytes of interest. Liquid always requires water removal, and that could be, through a sep funnel, and then your sodium sulfate. We can do automated water removal through the automated solid phase extraction system, and it's very fast and unattended. The other thing this does is it separates your organic from aqueous waste. Super important for disposal reasons and costs. With liquid, there is no separation of waste. It's just going to go into one thing and have to go as an organic waste to be disposed of. You have a lot more volume, as we discussed, to evaporate, and emissions, again, is a big problem with liquid compared to SPE. If you're doing continuous liquid extraction, you have very high electrical costs, and basically these systems can be paid for in like 2 months if you replace the continuous liquid with those 250 watt heating mantles. They use a lot of electricity. This uses like a tiny fraction of that power. So just that alone usually is enough to get your ROI back. And again, of course, solvent, you're going to spend less money on solvents and less money for disposal. This is just an example of emulsions and SPE extracts that come out of the system. For example, A and B, that's like an acid for your ABN, that's the acid portion, and then the B is the base portion of a 625 or 8270 or semi-volatile extraction. And again, reduced solvent volume, it's 60 mil would be a very large SPE extraction. Typically, they're anywhere from 20 to 40 mils. Just to give you an idea of the types of methods that are covered, they handle all of the EPA 500 series, which is the drinking water methods, and those are all listed here by method number and analyte classes and types for those folks that are, watching internationally. Your nitrosamines, chlorinated acids, your semi-volatiles, pesticides, flame retardants, phenols, explosives, the PFAS, PFOS, there's several of those, and endothol, paraquat, diaquat, PAHs is also a very, big method that's run around the world, and then these others as well. The first system we're going to talk about is the Econotrace system. It's strictly for clean matrices, so drinking water, we have a picture of serum here as well. You can see you can have up to 5 solvents with this system, and this is showing 6 samples in parallel, but it actually is capable of doing up to 8 in parallel. It's fully expandable up to 4 modules to get to 8 positions. So you see here you have 2, 4, 6, and then if you add another module, it would be 8. So it's very high throughput. It's going to run 8 extractions in parallel at a time. It's positive pressure for the delivery of your solvents, your sample, and your elution. It's going to separate that waste. It's fully automated, so this rinse bottle here is automatically filled with the bottle rinse solvent by this pump here, and then it's delivered to the sample bottle by nitrogen, and that's your automatic bottle rinse. It's going to nicely rinse this whole bottle automatically, and it's going to deliver it automatically to the concentrator here, the SuperVap, and it's going to start the blowdown once the sensors detect the solvent hitting the SuperVap concentrator. It's got a touch screen for control. Your SD cards here in the front are used for storing and transferring all of your methods. You have nitrogen drying. There's a setting here which is going to allow you to set and control the nitrogen pressure. You have 6 solution and wash solvents. It's really 2 mils to unlimited. You would just extend your sample bottle tube to wherever that needs to go. Say if it was 50 liters, 4 liters, you'd move that out to be able to take those larger samples, and then your automatic bottle rinse. You're going to have a real-time graphic display, which has an LED. They have LED lights that show the pathway of where each step is going. So in other words, if it's going from solvent 1, it will show solvent 1 going across cartridge, the cartridges to organic waste, basically for conditioning, and so on and so forth. Same with sample loading, etc. Again, direct to vial concentration and positive pressure pumping for consistent delivery of sample and solvent. Again, the sample sizes are unlimited. Here's an example of some of the bottles that folks use. We adapt this cap here with our fittings, a rinse bottle fitting and a sample sipper line that goes in there. So those can all be taken apart, replaced, etc. very easily. It's not a custom type of a cap. Here I'm just showing a lot of different cartridge types that can be used. Any vendor, etc. We have cartridge manufacturing here. We guarantee the results of those cartridges. When we pack them here, they're all tested for the individual applications. But we don't prevent you from running other types of cartridge chemistries. Here's an example of some drying cartridges. Here's some small ones here. We don't find that those work as that well, right, Rude? I mean, they're not really the best. This is one that we make, and we put quite a bit of sodium sulfate in there because we want the analyte to be, the extract to be dry, and we don't want the analytes getting bound up in in the small packing material, because that's what happens if you overload that smaller amount of sodium sulfate. Then you're going to start to get encapsulation of analytes. So with that, I'm going to have Rude cover some of the different types of methods that we do with this system.
I think it's okay. This is method 508, which is one of the main OCP organochlorine pesticides. Drinking water method in the US from the EPA is about 18 regular pesticides, and also PCB 209. And as you can see, all the recoveries are 70% or higher, and up to about a 120 with error bars showing good reproducibility. The 522 is 1,4-dioxane. We have some results here. You can see recoveries very close to each other. These are all multiple replicates from 82 to 89% with a very limited standard deviation. And we spike with 1 microgram per liter, and that's pretty much what we find back here. 525 is a drinking water method for semi-volatiles, has a significant overlap with compound-wise and likewise with the 625 semi-volatile wastewater method. And here again, also OCPs, all pretty much 80% and higher with low error bars, good reproducibility here. These are the semi-volatiles that are in the 525.3 drinking water methods. This is just a compounds that are structurally quite different that we just put in one table here. There's here 1 pH here, chrysine, and some other pesticides, hexachlorobenzene, molinates, but again here, good recoveries, anywhere between about 80 and 100% with good error bars. Some more here, again, same story, 80% and higher, low error bars for a variety of pesticides here, and that are also at the same time semi-volatiles. In the next slide, you will see PAH and phthalates. All recoveries here even higher actually, pretty much all 90% to about 100%, very low error bars here, almost difficult to see, very good reproducibility. There's some PAHs here and phthalates shown here. Then we have PCBs in drinking water that we here just reporting the totals of each congener from mono through hepta PCB. And you can see again very good recoveries here between about 85 and 105% with low error bars. 529 is an explosive method that is done mostly some nitrotoluenes and nitrobenzenes in this method. Again, very good good error bars, good recoveries, anywhere between about 180 and 105%. Anosol is probably the last slide that we showing for the drinking water. You can see here we ran a number of replicates, and they're all with very good recoveries at 95 to 98%, and here about 103 to 111%. Oh, there is actually some more diachron and paraquat, two compounds that are often run together in the US in method 549. And again, good recoveries between 85 and 93% with small standard deviations.
Yeah, just to mention some of these methods that we're showing here, the Econotrace is a real workhorse. We have folks that have been running the Econotrace for some of these methods that Rube just showed you for 10 years with the same system, paraquat, diaquat, some of the explosives, 525. So it's a system that's been around for a long time. It's very robust and rugged, and no cross-contamination. All of the pathways are individual, basically. And so you avoid sharing pathways of the sample or any of that type of thing. So the TurboTrace, which is we're going to talk briefly about, is also solid phase extraction, but it's made for all types of liquids, basically. So if some drinking water folks, they're doing those tests on groundwater, they're doing it on wells, and those can have some high particulates, depending on, what time of year you're sampling, and so on and so forth. So we use the turbo trace to solve those issues or deal with those types of tougher matrices. So when we're talking to you, that's why we ask about, what types of samples, what type of water is it, what analytes you're looking for, how many are you running. That's all to figure out exactly what system is going to work best for your sample prep workflow. So again, it's a fully automated system. It's actually expandable from 1 to 8 modules. It's going to run everything in parallel. It's going to use the positive pressure for the delivery of elution and wash solvent, and it uses the vacuum or positive pressure to load or pump samples across the cartridge. And the reason that we use the vacuum is that we are using the vacuum to have the least amount of tubing and areas for potential obstruction for dirty or dirty types of samples. And again, going directly to the concentrator for final blowdown once the extraction process is complete. Same types of things we talked about earlier. These are all pretty much the same. You have the same amount of elution and wash solvents, SD card, touchscreen for programming, your automatic bottle rinse. And the sample size, again, is unlimited. We use a liquid level sensor when loading the sample with a vacuum, and I'm circling that with this pointer. So it comes directly out of the sample, it goes across that liquid level sensor, and so it's monitoring that tube. And so when we see a change, in other words, when there's no liquid going through that tube and you can set the time, you can set it for, 5 seconds, 10 seconds, 30 seconds, 90 seconds, it depends, and then that will shut off the delivery of the loading the sample. That way we're assured that all of the sample is loaded across this cartridge, and this sample bottle is ready to be rinsed. So this is capable of doing very fast flow sample processing. So you can do, many mils per 100 mils per minute if you want. And there are some methods that you can rip the sample across the cartridge to get things done quickly. Most analytes don't like to be pulled across the vacuum material that quickly, but it is capable of doing that. The vacuum allows that to be done. So Rude's going to talk now about some of the methods that we focus on with this. And
this is the 1613 method, dioxin furans. You can see here again really good recoveries, anywhere between 75 and 105% for both furans and for dioxins. And I think the next slide is 1668, PCBs in water. You can see pretty much every PCB between 1 and 206 giving good recoveries. So you can, if you want to analyze all PCBs in water, then this is a really good system to do that, because recoveries are pretty much 90% for all of your PCBs in existence. PAHs, same story, very nice recoveries between 80 and 100%, good reproducibility, small error bars. I think this is about 17 or 18 shown here, with going from naphthalene, which has 2 rings, to the ones I think with like 5 rings, like the Indeno 1, 2, 3 CD pyrene. So a wide spectrum of PAHs can be done with a turbo trace, giving you very nice recoveries.
we also have SPE systems that are specifically designed for PFAS and PFOS extraction. These are the existing EPA methods for drinking water. All of the materials, 533, 537.1, everything is inert in this system. There is no Teflon in the system. This system in particular, we're showing PEEK and stainless steel and high-density polyethylene tubing is used typically now. Systems can be made in PEEK tubing. Some folks have us do it in PEEK. And then again, this system, any of our existing drinking water systems are easily converted to the PFAS and PFOS extraction system. We call it the EconoTrace PFC or the TurboTrace PFC. And these take on the attributes of those systems, but it's strictly for the extraction of PFAS and PFOS. We have also the only concentrator developed for the analysis of PFAS and PFOS. And all of the tubing and nozzles, et cetera, are high-density polypropylene, PEEK nozzles. There's, and this is to eliminate the possibility of any, contaminants from Teflon tubing, et cetera, entering through that nitrogen pathway. It's also designed for 15 mil conical vials, which are centrifuge tubes. Okay, with that, I'll hand it to Ruud.
Yeah, we have some results here for 537.1, run at 250 parts per trillion nanograms per liter. And as you can see, this is a so at 18 or 20 PFAS shown here with very nice recoveries, anywhere between 80 and 120% recovery. Background-wise, the systems that we produce are very low. That is both true for the fully automated, and also I think we're going to maybe show also semi-automated PFAS equipment. Before is a little bit higher because it's very high background. In the environment, but pretty much for most of these PFAS, the background concentration is less than 0.05 nanograms per liter, and because we went to great length trying to avoid, or actually completely avoiding that long in our system, you can see that pays off. There's very little cross-contamination risk for your samples.
Yeah, so these would typically, with this, for the drinking water, we've gone up to, 100 nanograms per liter with the run, then do the cleaning program. It has its own automated cleaning program. All of these systems do actually. And this is what you can expect after running the cleaning program once. So it does a very good job of making sure there's no cross-contamination from sample to sample.
Yeah, EPA 533, which is again about here, I think maybe even like 22 or 25 compounds shown with error bars, very nice, 80 to 120%, good reproducibility, and also some of the more recent PFAS compounds like the A2 and AM42 and 62 FTS shown here. Very nice recoveries.
So to summarize, why would you automate your water extraction process workflow and automate with solid phase extraction specifically? You're gonna do everything in one step. It's all hyphenated, so you're gonna do the extraction and concentration in one step. It's gonna reduce errors, reduce labor or technician time, which is very important and a focus today with the way everything's going in the labs, et cetera. You're gonna reduce solvent usage, and you're gonna increase your sample throughput by automating these processes. So it's going to automate and combine the extraction and concentration steps in the sample prep process here, and that's going to eliminate any human error that can occur. They just have to load the sample, make sure the sample's spiked, make sure they have plenty of solvent, and that the waste containers are empty and they have their the vessels for collecting the extraction in place. You can do inline concentration with the sodium sulfate cartridges going directly to the GC vial, which basically is going to take it to its final volume of 1 mil. Then you're going to put it onto the GC auto sampler and directly inject it. This provides the fastest automated sample processing available for cartridges or columns. It's going to handle a wide range of samples, matrices and sizes, all SPE cartridge and column sizes. We have column adapters, cartridge adapters that we make here at FMS to fit all different manufacturers as well as our own. These systems comply with all existing worldwide methods that require vacuum, positive pressure, and precise delivery of sample or solvents for these methods. You can also program and store an unlimited amount of methods. This can also be used as a R&D tool for methods development. You can program the system to basically do whatever you would like to do when trying to look for new compounds. So that's particularly of interest when you're working with a lot of these new emerging compounds such as PFAS and PFOS. You need the flexibility to be able to try different chemistries as well as solvent conditionings and elution. It's a very green technique. It's going to reduce your solvent use, disposal cost, solvent emissions, and it separates the organic from your aqueous, again, saving you money and less waste, organic waste going to the to wherever they dispose of those wastes. The FMS is a fully automated SPE system that's going to deliver consistent, reproducible results, time in and time out. Again, we talked about the drying using sodium sulfate cartridges. With that,